In this video, I'm going to talk about the hybridization of atomic orbitals. This is a topic which students find difficult to grasp. So I'm going to use a simple language and some analogies to explain the concept of hybridization of atomic orbitals. Now, the earliest and the simplest concept of covalent bond formation was through the sharing of an electron pair in order to complete the octet of electrons. As you can see, chlorine has 7 electrons in its outer shell, and when the two chlorine atoms come together, an electron pair is shared between the two chlorine atoms, and each chlorine atom acquires 8 electrons, the octet, and therefore a covalent bond gets formed between the two chlorine atoms, which can be represented like this. But as newer theories developed, it was realized that electrons were not simply the particles, but they also possessed wave nature. And similar thing happened to the nature of light. Light was considered to be having a wave nature. It was supposed to travel in the form of waves, but later on a modification was introduced where light was also supposed to be having a particle nature in the form of photons. So a similar change happened about the understanding of the electron, where it was realized that the electron also had the properties of both particles and waves. And therefore, this simple concept of electron pair sharing between the two atoms to form the covalent bond had to be modified in view of the new developments. And as many of the students would have heard, that the science or the branch of chemistry which deals with the concept of electron as particle as well as wave is called as quantum mechanics. And quantum mechanics developed as a result. But quantum mechanics is very difficult to grasp by the common students because it is highly mathematical in nature, and to understand quantum mechanics properly you need to have a solid background in maths, which at this level most students don't possess. So we will not go into the details of quantum mechanics, but we will only deal with the results that come out of quantum mechanics. Now, one of the changes that happened was that the electrons were now supposed to occupy orbitals. Now, what are orbitals? Orbitals are the regions around the nucleus where there is a high probability of finding the electrons. Now, the term probability was introduced because, according to the modern concept, it was impossible to know the exact location of the electron because of it having a wave nature, and therefore we could only talk about the probability of finding the electrons, and those probabilities could be determined by quantum mechanics. So the concept of the covalent bond, which was supposed to be formed by simply an electron pair sharing, was replaced by a new concept in which there was supposed to be an overlap of the half-filled atomic orbitals. Half-filled means that it contains only one electron instead of the 2 electrons which are permitted to fill up an orbital. Now take this example where electron pair is shared between the 2 hydrogen atoms to form a covalent bond. Now we say that the s orbitals, which are spherical in shape, each possessing in hydrogen, each s orbital possesses 1 electron, so it is half filled. And when 2 hydrogen atoms come together, then the orbitals overlap, which results in the formation of the sharing of the electron pair and hence a covalent bond gets formed. It's important to understand that this overlap is not a physical overlap. It is just that the probability distribution of the electrons gets altered when the two hydrogen atoms come together. Now, there is a greater probability of finding the electron pair in the region between the two nuclei, and therefore the negative charge present in the electrons and the positive charge present in the nucleus, that electrostatic force of attraction is actually responsible for the bond which is formed between the two hydrogen atoms. Now let's go to why do we need the concept of hybridization. Okay, so now if we consider carbon to introduce the concept of hybridization, we find that carbon has the following electronic configuration: 1s2, 2s2 and 2p2, which can be represented in this way. But since there are only two half-filled orbitals, the valency of carbon is only supposed to be 2, but in fact it is 4, as is seen in so many of the organic compounds. So to overcome this difficulty, it was suggested that it was possible for an electron to jump from a 2s orbital and then go to 2p, giving rise to 4 unpaired electrons or 4 half-filled orbitals, which would then be used to form 4 covalent bonds of carbon. But here again we are faced with another difficulty, and that difficulty is that even though carbon can form 4 covalent bonds as seen in the electronic configuration, but still all the 4 bonds formed by carbon are not going to be equivalent, because 3 of them would be formed by using the p orbitals and 1 bond would be formed by using an s orbital. Now we have to somehow explain that why the 4 bonds of the carbon are equivalent. At the same time, we have to explain the bond angles, because the bond angles which are formed in methane, as you are aware, are 109.5 degree, that I have shown in this diagram, that the 4 bonds all are equivalent to one another and the bonds make an angle of 109.5 degree. Now carbon has p orbitals which it can use for bond formation, but the p orbitals are located or directed mutually at 90 degrees to one another, px, py, pz. So if these orbitals are used, we can not explain why the bond angles in methane are actually 109.5. So in order to overcome these problems, it is suggested that older orbitals are modified into new orbitals, and this process is known as hybridization, where because we involve 1s and 3p orbitals, it's called sp3 hybridization. You can also have sp2 hybridization, where 1s orbital and 2 of the p orbitals combine to form new orbitals, and sp hybridization, where 1s orbital simply combines with 1p orbital to form sp hybrid orbitals. Okay, now if we try to explain this, so we have we have one electron in the s orbital, and we have these 3 p orbitals, right? Now we mix them together. Now the s orbitals are spherical and the p orbitals are dumbbell shaped. Now when we combine them and then recreate new orbitals, now the new orbitals that we will create are all having the shape of a large lobe and a small lobe, because it has some of S character and some of the P character. So the new orbitals are all of this shape, right? And because of the mutual repulsion between these four orbitals, they will obviously become what we know as the tetrahedral shape, and that is the shape wherein there is maximum stability due to minimum repulsion. So once these sp3 hybrid orbitals are created, which are all identical to one another and which are formed by the mixing and recasting of these s and 3p orbitals, is called sp3 hybridization. So now we are able to not only explain why the four valencies of carbon are formed and why the four bonds are equivalent, because all the four sp3 hybrid orbitals are equivalent. At the same time, we can also explain why the bond angles are 109.5 degrees. So I can explain you this with an analogy that let's suppose that we have an old house which has 4 rooms. Now these 4 rooms are all different from each other, correct? They're all different. But what you do, you renovate this house. And when you renovate this house, you break all these 4 rooms and then you create 4 new rooms. And though these 4 new rooms are all identical. So this is what happens in hybridization, that from the old orbitals, which were different from one another, we have rearranged these 4 orbitals, we have mixed them together, and then each of these orbitals loses its identity. So the new orbitals formed are neither s orbitals nor p orbitals, but they are all identical to one another and they are called sp3 hybrid orbitals, right? And here the s orbitals of hydrogen can overlap and form methane molecule, right? Now it is you have to understand that why this can happen. The smaller lobe here we have omitted because the smaller lobes don't take part in the overlap and in the bond formation. Now what you have to understand is that orbitals are not something rigid which cannot be modified. Carbon has s and p orbitals when it is not combined, but when it combines, when it comes under the influence of 4 other hydrogen atoms, its orbitals can get rearranged to suit the environment. This can be easily understood by considering that new kinds of electrostatic forces of attraction are developing between the carbon and the 4 hydrogen atoms. So the electron distribution which was present in the carbon when it was in the uncombined state, and now the new distribution of electrons around carbon when it has combined with 4 hydrogen atoms is not expected to be the same. And hence the concept of hybridization can easily be understood as a new arrangement of the electrons when it comes under the influence of other atoms, and when it binds with the other atoms, we expect the electronic distribution around the carbon to rearrange, and to suit the environment it forms new identical arrangements around the carbon atom, which can be supposed by using the language of hybridization. In the same way, other kinds of hybridization can also take place. So in that, we modify the old orbitals and recreate new orbitals which are all identical to one another, and this kind of process is called as hybridization. This can be mathematically proved by quantum mechanics, but we don't need to go into quantum mechanics at this stage. Thank you very much.